DIMM plugs, that was the idea that I had as far as how to send out the infrastructure. Any questions on that so far? No?
Will be the applications for those cylinders, actuators.
Which ones, the linear or all of them? There's a lot of cyclical testing that has to be done with these plumbing.
Open close the pressure faucet.
No, just movement. So like, alright, a faucet, great example. The faucets have 3 points of movement. You've got the hot knob, the cold knob, and then you've got the neck of the faucet that moves around, say like a kitchen sink. You have to move all of those components a certain number of times. I think it's like 20,000 times, 50,000 times, stuff like that.
Yeah, 100,000.
Yeah. Toilets, dual flush toilets have to be cycled. Just flushing them on, off, on, off. One of the standards for the soft components of toilets, the flappers, the valves, the fill valve, all that stuff, you have to raise the flapper up and flush it like 50,000 times. So that's what the application is for these. Is just to do the hard cyclical testing on a component, just movement test. It's kind of like with the binders, but you're actually using the real world movement of it. So that's why the actuators, the rotary actuators, the linear actuators, is basically just to move the pieces for whatever plumbing parts. So you've got faucets, you've got toilets, mixing valves for showers and bathtubs. Those have to be cycle tested. There's a few other things that I'm not thinking of right now. Pretty much anything that has a movable handle has to be cycled so many times. And the standards call out, there's certain figures and tables in each standard as far as how many cycles in what direction, all that jazz. Now, the software component of all this. Well, first we'll talk about the wiring. Now, I beat my head against the wall for like 2 weeks straight trying to get the wiring right on this. Came in, I called the engineer from Clayton Controls. He came in and in 10 minutes he set me straight on this. Because I didn't realize you have a power supply that goes, so this is your power supply, this is your PLC. Alright, this is the cable that goes to the USB port to program it all. You notice right here, this red, white, and this green, which is not hooked up, this is just a ground wire, so it all goes to common. But these two power supplies are the main power supply to the PLC. So, and I was thinking it in the lines that you have the power in and power out should come out of these terminals. It wasn't true. All these things have to be hooked up directly to the power source. So what I got is I got 3 common bars, positive, negative, common, ground. So, and I'm going to wire everything to these, and then you can draw your juice. So if you look, this is actually the DIMM plug for the actuator. So on the output side, you have your positive that goes straight to the positive end on the power supply, and then your negative goes to whatever port you assign it to. So this one is in Y0. So, and you see the labeling. So you've got your positive that goes to the power supply, your negative that goes to the output terminal.
So it's a switch.
It's essentially a switch. That's basically all it is, just turning it on and off and on and off. But the problem is, like, you got to do it so many times and you've got to hold it for so long, and there's a lot of different variables.
Right.
So, I mean, otherwise I would have just put a switch on the wall and just go, okay, there it is, on, off, on, off, on, off. And that would have cut a lot of this headache. But the problem is not that simple.
Right.
Now, the input devices are similar, only you have 2 leads that go, one to the positive, one to the negative, and then one lead that goes to your input terminal. So that's how they're wired in. So output terminals, positive to the power supply, negative to the output terminal. Sensors and switches, positive and negative to the power supply, common to the input terminal. So the output terminal has its own power supply also. So there's power leads that go positive and negative to the PLC. Now, if you have any problems with the wiring or the programming, the guy who came out here